This talk is API keys. Now what? Yes. So we're taking the pen test into the Amazon cloud, and basically, if you're here for GCP or Azure, I may have a couple of tips for you, but it's primarily going to be an Amazon talk. As I said, my name is Jim Shaver. I go by Elitist most places around the web. The overview of this talk, basically, we're going to talk a little bit about what AWS is, what API keys are, and what do you do with them, how they work a little bit. We're going to talk about what tools are out there to help you. And we're going to show off some examples. We're not doing any of these in any particular order. It sort of goes in this order, but we're going to bob and weave a little bit as we go. And then at the end, we're going to talk about some other resources that can help you. So the first question is, what is AWS? And most people, when they think about AWS, they think about primarily two things, EC2 and S3. EC2 basically is the virtual machine part of AWS, and S3 is the storage part of AWS, the shared storage part. But AWS is a lot more complicated. I feel like I find out about a new part of AWS like every week. So, and they are also releasing new parts of AWS all the time. So just know that it's complicated and it can do a lot of things. AWS is not Active Directory, but I think like the Windows analogy is not terrible. So I'm going to use it a little bit. If you think about what Windows is, it does a whole bunch of things, or it can do a whole bunch of things if you turn those things on. And all of these things fulfill a need. So some of these things are virtual machines, some of them are shared storage, some of them are email, DNS, etc., and IAM. And Amazon has things that are complementary. Now, Route 53 doesn't work exactly the same as Microsoft DNS, but they both do DNS. Okay, so it's good to think about that. There's more to AWS than just those two things. We're going to primarily talk about EC2 and S3 today, so that is sort of the focus of the talk. Next, we're going to talk about what are AWS API keys. Okay, and first we need to understand how authentication works within AWS. So when you authenticate to the AWS console, which is basically the web UI for AWS, you're generally using a username and password, and you may be using MFA to log into the website. Okay, that is your authentication. When you authenticate against the API, you're using API keys. Okay, this is what AWS API keys kind of look like, so that you know what they look like, so that you can find them, basically. And we're going to talk about how to find them a little bit later, too. Sure, yeah, and these slides will be later. The key ends in example key, so I don't think these keys are valid. Something tells me. The random number generator is just not that good, or not that bad, I guess. Okay, so we're going to talk about some tools today. I've got a big long list of tools at the end as well that you can dive deeper into. I've split them up into two sections. We're going to spend most of the time on the stealthy side of things. There are also some louder tools that are a little bit more audity, I would say, on the audit side of things. But basically, AWS CLI is a really good place to start. It's basically, I want to run a command against the AWS API. And then there's Boto 3. Why is it named Boto? Well, it's a dolphin that lives in the Amazon River, so some smart person was like, that makes sense. And I guess this is the third version. So, and basically, Boto is the Python SDK for AWS. Okay, so most of the tools that you've ever used that are written in Python for AWS are probably written in or using Boto 3. It's also Scout 2, which basically, if you're a blue teamer, if you're a red teamer, and you're like, we just got this new AWS thing, how do I keep an eye on it? Scout 2 is like the base level that you should be doing. It is like the Nessus of AWS. It'll generate you nice, pretty reports that you can tell your AWS cloud team that, hey, you're doing this bad, you're doing this good. It's a good starting block. And then cartographer is from the people at Lyft. Released a couple of months ago. I've talked to lots of AWS people, and they've never even heard of this thing, so I guess it's just so new that it's new to a lot of people. But basically, it's if you're familiar with Bloodhound for the Windows world, cartographer is basically Bloodhound for AWS. So you can do queries and have nice, pretty circles that connect to each other and that type of thing. And we'll take a look at what that looks like as well. So the first example that we're going to talk about is the subdomain takeover. This one doesn't require really any authentication into your target environment at all. So this one sort of stands alone. And this is part of S3. So this is an S3 bucket. And all you need to know about an S3 bucket is it's just a container for data. It just holds files and folders. And you can copy stuff to it. You can read stuff from it. It can host websites. Some people stopped hosting their WordPress sites and started taking static copies of those websites and putting them into S3 buckets because it's a lot more secure than running WordPress. So basically, the way an S3 bucket is there's you can technically make the S3 bucket name anything you want. So it could be like just a bunch of random gibberish .s3.amazon aws.net. But they really prefer you to use like DNS compliant names. So this is, I own the domain hack.lol. So I've created a website about my hacking adventures, I guess, called info.hack.lol. And I want to host it on S3. Okay. So this is the DNS record, in fact, for that website. Okay. And the website is a bucket. It has 3 files in it, an about page, that is HTML, an index, and a contact page. So the way the subdomain takeover works is nobody's going to type that big long DNS record into their browser. So you create a CNAME record, info.hack.lol, that points at the longer record that then in turn Amazon points at a managed IP and it's sort of geo-located around the globe. Magic happens in the Amazon cloud. Okay? So the thing that goes bad is that sometimes websites go away, and so you're no longer hosting this website, but you keep the DNS record. Okay? And what a bad guy could do is he could look at all your DNS records through DNS Dumpster or whatever, and see that you have this DNS record that doesn't go anywhere in Amazon, and they can register that bucket, because if it's not registered, anyone can register it. And then they can put whatever they want in the bucket, do defacement and that type of thing. And then they now control what shows up when somebody goes to info.hack.lol in the browser. Okay? So that's the subdomain takeover. Basically, the fix for this is make sure when you decommission static websites that are buckets, you also decommission or change the DNS record. Okay? So that's a super simple example. We're going to do another more complicated S3 example around weak permissions. Okay? So this is secrets.hack.lol. And basically what's in here, I've got all my good AWS credentials and passwords and keys and stuff. I guess it's all in keys. So there's a Git repo. We're going to see what's in there. And then there's a PEM file, which is basically like an SSH key. We're going to see what that might be useful for a little later. Okay? And this is an AWS permission statement. It's written in JSON. And it's kind of like, you can think of this as like a Windows file system ACL. That's kind of the analog here. Okay? Now this technically isn't a valid permission statement. I've combined a few things just so that it fits on one slide, but I've got all the important things in here, so the people who are real cloud people don't yell at me. But basically, there is so we're adding permission. That's the name of the policy that we're setting. The permissions we're adding are get object and list bucket. get object you can kind of think of as read. List bucket you can think of as list. And then we're adding it to the resource secrets.hack.lol. That's the name of the bucket. Okay. And normally these are not like inherently bad permissions to add. The problem is that we've got this one tiny little star that is the principal, and basically what we're saying is we're giving all this permission to every person globally around the world. Okay? So everybody who can get to S3 can read what's in this bucket and also list what's in this bucket. Okay, so what does that mean as an attacker? How do I actually operationalize or attack this? Okay, so the way you do it is with one of the ways you can do it is with the AWS CLI. There are other tools that'll do it too. And basically how this works is we're running AWS, which is the command. You can install this via pip. AWS, the subcommand is S3. We're running an ls on the resource, which is secrets.hack.lol. We want to recurse, so we want to show everything in every folder. The no sign request. This is the important part of this. We're not actually logging in. We're not trying to use our API keys, or if we have API keys. We're just saying we want to be anonymous and not actually authenticate. And because of the weak permissions, this actually succeeds. We're able to list the information that's in this bucket. Okay, and we see that as an attacker, we see there's some interesting stuff in here. So that's great. What do I do with this information? Well, there's a AWS S3 CP copy command, but sync is probably, because there's a large number of files. You can do a sync, source, destination, again a no sign request, and you can even sync between S3 buckets if you want. So you could say, I want to go from this S3 bucket that I'm attacking to this S3 bucket which I control, if you want. Or you could just go to your file system. It depends on how much data you have too. You don't have much room on your workstation, and you want to store it in the cloud. You can do that. So let's look at this Git repo. We've got a credentials file. This is actually an AWS credentials file, and our developers or whoever have created this Git repo have been smart and said, we're not storing our AWS access key and our secret key in this file. They've put a change this, in there, and that's good best practice. But at one point they had not done this, and an older version of the repo actually contained a secret key and a key ID. Okay, so the way we find that is we use a great tool called Trufflehog, and basically Trufflehog, you point it at a folder, also point it at a Git repo on a website, and it will go through and recurse through all the files in the commit history and all that, and it will look for stuff that looks like keys or other sensitive information. So in this case, it came up with a set of API keys. Okay, great, that's awesome. We found some API keys. So now what do we do with them? And actually, first, so where else can I find API keys? Right. So you can find them in code. You can also find, if you hack somebody's vSocial and get a shell in a box, you might be able to find it in a system. That's one of the reasons why attacking the API with API keys is a lot better than attacking the AWS console with the username and password, because API keys are left lying around all the time, a lot more often. Okay. You can also find them in environment variables. So there's a very common environment variable, AWS Access Key ID, that Amazon puts in their documentation, and and some people use it. So definitely check your environment variables when you get on a box, or if you're in like a configuration management, if you get into something that does configuration management, check what environment variables are being set. And then there's also a location in the home folder of a lot of users that use AWS on a regular basis. That's .aws/credentials. And basically this is what's called an AWS profile. And this is a way that you can, when you have to authenticate against against AWS over and over again, this is a way to do it. Okay. So that's what I mean by they're lying around in the file system all the time. You can also just search for AWS keys with grep if you want. So good things to search with are AWS key ID, secret, access key. AKIA is a really good one because that is the beginning of almost every access key that or every key ID that I've ever seen is AKIA. There's some exceptions to that, but that's pretty common for like user and system keys. And then things like API as well. All right, so I also have a couple of scripts that I have in a GitHub repo that you can take a look at. This is just a little bit of one, and basically this is using Bodo 3. So we now have a set of API keys. We need to check that they're valid, because oftentimes in a Git repo, if they've been committed and somebody has already found them, then the keys have been rotated. So we need to know, are these actually keys that are useful to us, or are they just garbage and they've been rotated already? So this is a simple script I wrote with Bodo 3, and basically it asks for the key ID and the secret. It runs a few checks, so it checks to see if the user is like a valid user or not. It also checks the username. So if you need to hunt down the person that belongs to these keys, this is a really good way to know who they are or what they're involved with. So if their name is first, or if their account is first letter last name, you know who to talk to. If it's an account related to databases or whatever, then you know sort of the general group that you may need to talk to. So the output of this script kind of looks like this. It says, it's a valid key. This is the username. What groups is it part of? What policies is it part of? And is MFA being used? Which is also a good thing to know, because just, good practice. All right, so the other thing we found in that secrets bucket was a PEM file, or a secret key. Okay, and there's a couple of uses for these secret keys. One of them is every Linux host that you spin up in EC2, which is every Linux virtual machine basically, has an initial user that you can connect to the box with. And when you create that virtual machine, you associate a secret key with that machine. And so if you find that key, you can probably log in as the user that is the first user on that box. Okay, and that's usually a very well-permissioned user, unless somebody's changed something. Say that again? Yeah, well, I'm going to get to that. Hold on. So, you're getting ahead. So, this is if the box is sitting on the public internet and, listening on port 22. That is an excellent point. Okay, we're going to talk about that in a minute. So, this is the first pen test for this place. So, they're not doing good things well. Okay. So, how do we get a list of Linux hosts? There's this complicated command at the bottom here. Basically, describe instances is a way to get information about all of the instances running within EC2. This one isn't perfect because you still have to parse through and remove all the Windows instances. The platform, it's a long story, but basically, not a good way to filter out Linux boxes. All right. Next up, Windows passwords. You can get Windows passwords out of AWS. Isn't that cool? So, the way you do it, so when you set up a Windows box in AWS, it's okay, I have this password, but it's encrypted. And the way it encrypts it is it uses the public key of that private key, that PEM file, to encrypt the password so that they can store the encrypted version of the password. And then when you need it, you can be give me the password. And they're okay, give me the private key. It does the decryption in the browser, and then it gives you the initial password on the host, right? Okay, so that's what happens in the browser. So, remember I said anything you do in the console, in the GUI, you can do at the API level, right? So think about how this actually works, right? So your username in the GUI, in the console, your authentication is username, password, multi-factor authentication if present. And then the decryption is handled by your private key. And that gives you a Windows password, okay? So that's essentially what's happening when you get that Windows password in the GUI, okay? How does this work at the API level? A lot simpler, right? So your API keys are the only authentication that you need, and your private key does the decryption, and then you get a Windows password, okay? This is also a script I have. It's up on my GitHub. You can take a look. Also uses Boto, okay? So, there's one caveat with this. Obviously, the password... Oh, there's two caveats. Because of... RDP needs to be listening on the internet for you to, like, make use of that password. And second of all, if they've rotated the password since the box was spun up, then this is not going to have the most up-to-date password. It's just the initial password, basically. Okay? So yeah, passwords not been changed, good luck. Alright, so this is the AWS networking slide. And basically, I'm not a networking guy, so I need some meme assistance, so I'm going to do the big explosive brain meme. Yeah, so basically, the first level of AWS networking, the Homer Simpson brain, is management interfaces on the public internet. So that's port 22 and RDP on the public internet. That's Homer Simpson brain. Okay, that's no good. So the next level is, and these second, third, and fourth level, they kind of you could take them in multiple orders. I like this order. So basically, you're starting to fire your synapses, limit network changes in IAM. So only let your people who know how to do networking in AWS. Okay, that's step 2. Step 3 is you could ACL off and just say port 22 and 3389. You can only get to that from certain IPs. It's you're starting to fire. The next level is VPN tunnels to AWS. So and I say VPC, so that's a VPC is a cloud network on Amazon. Okay, so basically the idea is you have a private network in Amazon, you have a private network wherever you're working, and you put a VPN tunnel that you can route through, and then you can SSH to the management interfaces through that tunnel. Okay, or have some sort of jump box, or whatever you want to do. So that's explosive brain, and then the Nirvana brain is obviously monitoring network changes and traffic. So that's I don't know if there's any other brains that we could fit on this slide, but basically that's what I feel like AWS networking is. And why this is important to know as a pen tester is if you can get them to move to step 3, you're probably out of luck. Okay, in terms of getting to those management interfaces. Okay. And you might say, well, why don't you put step 3 at step 2? Well, because developers are going to open up 22 if they have the ability to. So, okay, so that's AWS networking. There's another interesting thing to mention about AWS networking that I don't know that it's super useful for anything other than enumeration. If you have some ideas, feel free to let me know. But there's this if you've got a 169 address on a Windows computer, it's you don't have internet. Well, AWS was man, we can use that non-routable IP address and have it feed information within the virtual machine. So if you get a shell on a box that is running within AWS, you can get certain metadata about the box. Things like IDs, policies, security groups, network information, that type of thing. And you just have to curl this magic URL within the VM, or if you have a web shell or whatever. So an interesting note of about that, I guess. And that's kind of what it looks like. So you get information back. All right, elastic block storage. So within AWS, there's kind of a couple of ways that data is stored in EC2. All right, so if you have the base virtual machine image, that's called the AMI, Amazon Machine Image, I guess it is. And then you also have elastic block storage. So that's basically, I need to have more hard drives that are connected to this VM. Or I want to take snapshots, that type of thing. That's what elastic block storage is. So one of the things that happened at DEF CON was somebody gave a talk, Ben Morris, called More Keys Than the Janitor, and basically what Ben figured out is that there are a heck of a lot of elastic block storage, a whole bunch of elastic block storage devices, I guess, in AWS that are public, that have public permissions, a public read, essentially. Okay, so these are like hard drive images that have public read. So what he figured out was these EBS things are public and they're not encrypted. So you can encrypt the volumes, but that's work, and who's going to do that, right? So what he figured out how to do was from a totally different AWS account, take a snapshot that has been taken and then connect to it with a different AWS image and then read the data straight off the disk and potentially exfiltrate it however they want to. Okay? So I was going to write some tooling around this, but he was like, I'm going to release a tool. And I was like, oh, I'm not going to write anything then. I'm just going to wait for him to release it. So it's been since DEF CON, and he hasn't released it, so I don't know if people have contacted him or what. But basically, this should also be possible not across accounts. So if you're well permissioned in a environment that you're attacking, you should be able to take a snapshot and then just spin up an AMI and then connect that image and then exfiltrate the data however you want. So that's an important thing to think about as well. All right, so that's the stealthy stuff, the relatively stealthy stuff. The Scout 2 by NCC Group is a really good baseline tool. So basically, it also supports it also supports Azure in beta, GCP, Alibaba Cloud, and Oracle Cloud. Cloud. And basically what you do is you give it your API keys that have audit support. So those keys need to be associated with audit permissions within whatever environment you're assessing. It'll run a report, and then it'll highlight areas that need work or have issues or whatever. You can drill through the report and say, okay, what's wrong with the root account? Let's, figure out what we need to do to fix that. Okay. So that's Scout 2. Cartography is by the Lyft people and AWS Bloodhound, basically. So same audit permission. You run it against and upload data into a Neo4j database, just like with Bloodhound. It doesn't have the nice Electron front interface, so you actually have to write some of the queries yourself, and the query language is not too difficult to pick up. So, but what's really cool about this is you can write queries and say, okay, show me all the S3 buckets that have public permissions. Show me all the databases that aren't encrypted. You can write queries like that, and it will show it to you easily. There's other ways to do it too, but this one's pretty. So, other resources. So if you want to learn more about AWS, there's a couple of CTFs that are in Amazon Web Services, flaws.cloud and flaws2.cloud. I would say, and I wish I could give credit to the people who made them good. I don't remember who it is. You'll figure it out when you get there. But they ramp up in intensity pretty quickly, I feel like. But a lot of the early challenges will get you started, and there's good write-ups out there for them. So definitely check those out if you want to learn more. There's also a slurp. There's multiple slurps out there, but like this slurp is really good. It has S3 bucket enumeration. This one ties into search stream, so it will go through the search stream and for a certain domain and find subdomains that have been created via search stream, or well, that have been put into the cert. What's that? Cert transparency log, and then sucked into search stream. Tony Blix is like this crazy AWS person that has a lot of really good AWS tools. One of them is called Prowler. If you're like a CIS benchmark shop or you have like weird compliance requirements, it's probably a tool you want to look at. It is the most extensive set of bash scripts I've ever seen in my entire life. It's amazing that he's written such a sophisticated tool in bash. I'm very impressed. But it works very well. And it'll help you with your best practices, and it's a little bit easier to set up and run than Scout 2, I would say. So, and you can run it on a regular basis, a little bit easier. So, Tony Blix also has my arsenal of AWS security tools on GitHub. I would say some of these articles are good, and some of them are not so good, but they are broken down. He does put them on there. He does break them down into like offensive, defensive, defer, training, that type of thing. The other groups. So it's a good resource just to look through and be like, I didn't know about that. For if you're an Azure shop, and I'm hearing a lot more about Azure these days, like people that are migrating away from AWS, and or just like Microsoft is making it so expensive to be on-prem and so cheap to be in the cloud that people are going Azure. The NetSpy people have some tools around Azure, not a ton, but decent amount. And then of course they're all in PowerShell. So there's that. And Derbycon has meant a lot to me in the last 3 years, and part of the journey is the end. I want to really thank all the volunteers that do AV and setup and takedown, and Dave Kennedy and everybody who volunteers. It's really been a great con, and it's meant a lot to me. So thank you. So my name's Jim Shaver. I go by Elitist most places around the web. I've got those scripts up in GitHub presently. The presentation will probably be up in a day. And just hit me up on Twitter if I'm lagging. So with that, I'll take your questions. Yep. Yeah.
My Windows background is very different. So Windows instances on AWS, we're talking about how like console can like get the password out.
Yeah.
Do they require password rotation using by default?
I don't think so. I mean, and sometimes Windows instances that are set up in... Oh, yeah, sorry. So the question is, do the AWS Windows instances require password rotation? I'm not sure. I don't think so. Anybody know that answer? I don't think so. No.
So, like, you had, like, the really cool, like, MFA bypass with the API.
Right.
You get this, like, Windows password, you get, like, new console access. You mentioned that, like, you can use it for RDP.
Right.
Is it only work for RDP, or can you, like, maybe, like, does it work, like, on an R?
So the question basically is, like, if you get that Windows password, can you use it for other things other than RDP? Well, RDP is the most likely thing you'll be able to do, but, like, unless you're, like, internal, doing, like, like, if you're on the LAN of the corporation and you can route to the box over an internal IP through, like, some sort of VPN, the only thing that you should be able to get to is RDP. Let me put it that way. So 445 should not be listening on the web, or on the internet, rather. Yeah.
AWS actually provides a vertex to go find access.
Okay.
They don't all start with APIA, so you can Like,
Okay.
you can totally dump out like all the histories and then like just run the Reddit for all of them.
Okay. So Amazon, there's a regex for AKI basically, AKI alternatives.
The 169.54.
Yeah.
Actually, one that endpoint's different in ECS, which is the container service.
Okay. It's different in, so that 169 address is different than in ECS. Okay. Okay. Okay.
But you get another one that will get you. And then we're talking about that like metadata URI.
Yeah.
Reverse that. It's pretty productive. It wants to get you API.
Oh, really? Yeah, I've seen that, but I'm like, I don't know what I would do with those. So there are API keys that you can get via that 169. So like, what do you do with those API keys? Okay. Gotcha. Okay. Cool. Yep. I'm sure. Yeah. It depends on their use of CloudTrail, but yeah, should. And yeah, it could also appear like, I mean, yeah, yes. The answer is, and the question was, shouldn't CloudTrail pick up on some of this stuff? A lot of this stuff, if you're looking at CloudTrail, you should be able to pick up on a lot of this. Okay. Other questions in the front here? Yeah. Yeah. Right. So let me distill down the question to basically, I get on a box. How do I pivot to something else? Is that the question? Is that fair? Yeah. So you can enumerate networking information through that 169 address. You should also. I mean, if you're on a VPC, if you're on a cloud network, when you're on the box, you should be able to. Like you should just be able to see what's on the network, just like a normal pen test. So you're just on an internal network from that point. So potentially. Question behind? Yes. Yeah, I think so. I haven't heard a lot about it, and I haven't seen a lot of them, so I think.